Okay, so rings on. Please do not swear. My name's Jodie Alliston. I'm pleased to meet you for the ones that I haven't already met. I'm a business unit manager for the solutions team at Northamber. Within the solutions team, we have two very exciting brands that we're bringing and presenting to you today, which is Scality software, and we're putting it on a Supermicro platform. I will allow both gentlemen to introduce yourselves. So we have Doug Williams from Scality and Sean Mullin from Supermicro. I'll let them do a short intro of themselves. Then we will go on to having a look at the presentation. Hopefully we'll be covering the markets, where the product's most suitable, the best customer fit, and a bit of product knowledge for you as well. Bit of housekeeping, if you have any questions, at the bottom of your screen there's a little raise hand thing. Just click on that and we will do our best to answer your questions as soon as we can. And as I said, we are recording this, so it will be available on demand afterwards and we can send it out to you as well. So with that in mind, I'll put myself on mute. No need to hear from me anymore. And Sean from Supermicro, shall I pop over to you first?
Lovely. Thanks very much, Jodie. Hi everyone. So yeah, I'm Sean Mullin from the Supermicro UK team. So I'm a senior sales account manager here at Supermicro. I work really closely with Jodie and the Northamber team, as well as Doug on the Scality piece. And we're really excited to bring you today's update. For those of you who are less familiar with Supermicro, we're one of the world's leading IT innovators in server solutions technology. You probably heard the name for a number of different things across the server industry. We really do try and cater for a product for everything. One of the things that we're really excited about in today's update is the Scality offering that we've worked alongside Scality and the Northamber team to bring you guys. I'm going to let Doug and Rob talk a little bit more to exactly what the exciting piece is around this, which is the Scality software that's going to run on our Supermicro platform. But just to give a real kind of brief introduction to where Supermicro fits into that. So we are a leading hardware provider, and we've got a number of different storage solutions that we've tailored specifically for this Scality software itself. So the guys are going to touch on these probably in a little more detail later on. But on our website as well, you'll find that we've got kind of 4 key reference architectures that you can refer back to later on in terms of the 2 different server platforms or models that we've based our systems around, which are optimized for the Scality application. So yeah, we've started out with kind of 4 solutions from our perspective, and then going on to look at what Scality capacity you need on top of that. But that's not to say that we can't get a little bit more customed or tailored for your customers or your end users' opportunity, depending on what exactly they're looking to achieve. So I'll let the guys talk to exactly what the exciting stuff is around Scality and what they've got to offer, which is really, really innovative. And it's, yeah, I guess I won't linger on too much about the hardware side of things, but yeah, as soon as we get through that piece, I'll add a couple of words at the end in terms of tying that back to our hardware and how Northamber and ourselves bring the offering to you guys as well. So yeah, without much further ado, I'll pass over to Doug and Rob to talk to Scality piece.
Thanks, Sean. So as Jodie and Sean stated, Doug Williams, I am the Alliance and Channel Director for Northern Europe for Scality. We also have Rob Alton, who is one of my senior SEs, who will touch on the technical side of Scality, where it fits in, what ISVs we use. It's a new venture for Scality, partnering with Supermicro and a distributor. There's some exciting news coming out soon, and what we're trying to do with the bundles and make life a lot easier for you guys as the partners to offer file and S3 scale out storage. Rob will touch on this. We go from 200 terabytes to multiple petabytes and beyond. We have customers with over 100 petabytes of storage on a single platform. On the commercial sides, reach out to Sean and myself and Jodie afterwards. But Rob, if it's okay with you, Jodie, has he got permission for presentation?
Yes, he has. So just to third button to the right, yes, is screen sharing, so should be good to go.
He's left. I think he hit the wrong button for from the left. So whilst he's doing that, little about Scality. We've been in the business for 10 years. For the last 4 years, coming up 5 years now, we are in the top quadrant leaders. Hi, Rob. Quadrant leaders for IDC and Gartner. We are the leaders in scale-out file and object storage. There is certain products in the portfolio. The product's called Scality Ring. And we work on NEX86 platform, SMC. We also have just announced all flash version as well to run the Ring on for analytic data, etc., for higher spec speeds. Rob, over to you.
Okay, apologies for that glitch. I just had to do a restart of the browser, but here we go. So I'm going to present to you the technical aspects around the Ring, and including with the Ring, we're going to include Zenko, which is our multi-cloud controller. I can't really see if there's any questions being asked, so I'm going to rely on someone else to shout if there's a question, but feel free to interrupt at any time.
I'll do that, mate.
Yeah, great. Thanks, Doug. So Scality is most famous for our original product, which is Ring, over here on the left-hand side. Ring is our private cloud on-premise platform. It's 100% software defined, which is why we work great with companies like Supermicro, and we're excited to have the bundles that we can offer. And then we collect all those resources together and we present that as an object store. And I'll talk around some of the great use cases and applications that we fit really well with. Basically, the clue's in the name. The object store is incredibly scalable. All we do is we keep adding resources, more servers, more networking, more disks, and the Ring can just grow seamlessly. And then the other product is called Zenko. It's actually merged into Ring, and Zenko is the ability to use any cloud destination via the S3 protocol. So when we can combine the two products together, we can have an on-premise Ring, which can store a huge amount of data incredibly resiliently for a long amount of time. And we can also tier or move that out to the cloud, any cloud, as part of that workflow. So first off, we'll talk about the Ring and we'll investigate the use cases where we're a good fit at. So we're a software storage for unstructured data. So it's always good to qualify where we are not a good fit. And we're not a good fit for things like the small block random IO workload. So structured data like databases, VMs, and home directories. That sort of use case is not a good fit for us. But where we excel is where it's unstructured data. So large files, so think of media, think of medical archiving as well. So when you think of all these hospitals with X-ray machines and CAT scanners, we make a really good fit behind there for storing that data forever, because it's not going to change and you're going to need to be able to keep that for a long amount of time. Public cloud email, so this is behind service providers. So for example, like Comcast or BT, if you're a service provider and you're setting up your own consumer-based email product, then we are a fantastic fit for the back end of that, as well as any other public cloud services. So because we offer file and S3 from the same platform, we allow ISPs to start layering different services on top of that. And these services could be things like end user backup, or let's say an iPhotos type of repository. So end users could take photos and they could be saved over the internet to the Scality Ring. One of our primary use cases is backup. So we make a fantastic backup archive tier, and where we're seeing a lot of fit at the moment for is, for example, Veeam. So Veeam 10 have just released the ability to use an S3 cloud tier, and also they impose immutability on that as well. So we work very well with Veeam. We've got quite a lot of customers now that are moving over to Veeam 10, and they're layering the Scality Ring as an S3 target behind Veeam. So you would have a local high performance storage, then you would have a capacity based cloud tier, of which Scality is a great fit. And the benefits for this is it's on premise, So so you're used to that on-premise type of performance. It's scalable. It's within your boundaries, so there's perhaps no sort of domain consent of it leaving your premises. And as soon as you save it to Scality, it's protected. So we have 14 nines data durability, and that could be across multiple sites. So that backup is automatically, instantly protected against multiple sites, and it's super fast to restore from as well. So our key use cases are things like archiving, backup, media. Public sector is great because of things like the medical imaging, and also digital evidence in police forces. We've got a few use cases of police forces, or even things like call center recording. So we can sit behind an application that records all the voice calls, and they have to be kept for a certain amount of time for regulatory or safety purposes. And we're a great use case for that. Additional use cases, things like CCTV. So one of my customers uses the Ring as a target for a brand new sports venue. So they've got 850 CCTV cameras that are constantly streaming and saving data to the Scality Ring. Or things like AI or big data. So we've got some alliances with some software vendors like Weka that can process data in a HPC scratch sort of environment, then automatically tier out to an S3 object store behind the scenes. And that's sort of where a good fit as well. So some example of our ISV partners, we've got a list of about 160 that's accessible on our website. And this basically means that we're qualified against them, they're qualified against us, and or we've got some joint customers in production using that software on our storage platform. So I mentioned backup, so we've got all the big names here that you can imagine. So Veeam, Veritas, Commvault, some interesting ones as well. So let's say NetApp, so we can use storage pools behind NetApp, or HP Store One, so we can use those sort of dedupe appliances. So same with Dell EMC, we can use data domain that have the ability to tier out to an S3 target at the back end, so that S3 target can be us, as well as being the cloud tier behind any of these backup applications here. Some other interesting ones are big data. So I mentioned Weka IO in terms of HPC type of environment, but we also work well with Splunk. So I've got quite a few large scale customers in the multiple tens of petabytes of log collection data. So again, we work really well with Splunk, either as an S3 object or as a file system connect. And for Splunk, we're a good fit for cold and frozen, and in some instances, warm data as well. But obviously, you still need an SSD tier behind that to deal with the hot data. Interestingly, collaboration as well. So we've got a partnership with Satera. Satera can offer robo type of functionality, so remote office, back office, file services. They can offer a unified namespace across things like a Dropbox type of enterprise sync and share functionality, as well as presenting file systems. Comprise, so we can be behind a data mover, and we've actually got a new product called Scality NAS Archiver, which enables you to scan your primary file system. So this could be on expensive NetApp, for example. So we would scan that file system, archive the data out, allow really easy access with active stubbing, but then it frees up both, expensive tier one, expensive high performance tier one capacity, as well as freeing up those backup cycles that takes up. So it's a double win, if you like. And also medical imaging and archiving. So what is Scality? So we are pure software defined. So this is where I say we work really well with people like Supermicro. So we've got the bundles that prove we've been through some testing process. We basically sit on a Linux operating system, and we gather all those resources of those servers together, and we create an object store out of them. So like I said earlier on, the more capacity you add, the more networking and servers you add, the more performance we get from the Ring as well. So we are an object store, but we're a high performance object store. And some of the technology that we use will become apparent shortly as to how we can provide high performance. But I've got customers that use the Ring in the tens of gigabytes worth of throughput performance. So we can scale from anything from a 3-node ring on a single site up to a multi-node ring. So we can have as many servers as you like. We've got customers with 30, 40, 50 servers in a ring. And the technology of the ring means that you can spread those servers out across different sites to provide site resilience. The way that the ring is architected is there's no single point of entry. There's no sort of single database that manages everything. All metadata and data is spread evenly out across the ring, so you can deal with many failures of the hardware or the network at any point, and still with proxy around that, and we can still deliver the data durability. So on top of these resources, we layer what we call connectors. Now, a connector is just a way that the application accesses the data. So we can have either file connectors, SMB, NFS, or we can have object connectors. So S3 is obviously the de facto industry standard, but we can also speak to the ring using a Azure blob protocol. And we manage the ring using a supervisor like a web GUI and API or a CLI. And the ring is made up of storage nodes, which is where the bulk of the data sits. These storage nodes have anything from with a minimum of 10 spindles up to 60 or 90 spindles in the server. It has some SSD. Now we use the SSD or flash NVMe for metadata operations, just to give fast response on metadata. So things like browsing is quicker. And we also use that for understanding where the objects sit on the disk so that the system can easily access the component parts of the objects. Then obviously each of these servers has a connection into a networking. Basically in a stretched site configuration where we have multiple sites, the ring is fully synchronous. So we'll only acknowledge back once we know the data is safely committed. So therefore networking is an important part of the ring. And if it's spread out across multiple sites, then we need to make sure we have a good interconnectivity. If we don't have a good interconnectivity, then we can have two separate rings and we can asynchronously replicate between the two. So there's always a solution that we can offer to meet the needs of the customer. And that's part of the benefits of software-defined storage. So another benefit is scaling. So Scality, we can scale performance independently of capacity. So we can start off with a number of servers. I've got these shown here at the bottom, and these have one line in which indicates they're partially populated with drives. And this is where it becomes really smooth and clean for a customer to upgrade. So we've met their initial requirements. We've put some servers and some spindles on the floor, which meet their needs for the next year. But when it comes to the next project and they want to add more capacity, then we can just add more drives to empty slots, or we can fill those empty slots until the servers are full. Then once those servers are full, we just add more servers. And we can just keep adding more and more servers until we reach the performance or the capacity that the customer requires. Part of the benefit of this as well is, let's say these initial servers that the customer bought, they bought them with, let's say, 5-year support, but then the next servers, they bought them 2 years later and they have 5-year support. So at the end of 5 years, we want to replace these existing servers with faster, newer servers with higher capacity drives. So we can do that. So we add the new servers, we migrate the data, we remove the old servers, and we kept the service up. So there's none of these concepts of a 3 or a 5-year cycle of having to buy an entirely brand new storage system and then invoke a costly and risky migration of data. We just add the new servers, seamlessly move the data on the back end, and then take the old servers out, and the services remained up all of that time. So also we can scale performance independently of adding the capacity. So for example, in this instance, we've got SMB connectors. Each of these connectors has a certain amount of capacity. A connector, by the way, is just a software process. So it can be on a storage node, it can be in a VM, or it can be on dedicated hardware. So if we want more performance, we just add more connectors. And because these connectors are hidden behind a VIP, the applications have seamless access. So we can lose connectors, and that keeps us up, or we can just add more and more connectors to add more and more performance. And this doesn't have to be for SMB, it could be for NFS. So we could have a new use case that comes along, a new application requires NFS access. So we just spin up some NFS connectors or S3 connectors, and we just add those. So we've got flexibility from the capacity, the performance, and the use case point of view. So I mentioned earlier on that we have 14 nines data durability. So I'll talk about how we protect data on the ring. There's two ways that the ring protects data. And the system automatically decides which way it's going to protect it. And this is based on the size of the object that comes in. So I mentioned earlier on that we were a great fit for service provider email platforms. Well, this is our heritage. This is where we started. It's providing storage for those. And part of the workload here is you get small emails. So emails that are in the tens of Ks, and you generally get large attachments in the megabyte size. So we designed a system that could cope with both small and large files or objects at the same time. So in this example, a small object is going to get written by an application through to the connector. The connector is going to understand that it's a small object. And what we do with small objects is we replicate them, or we make copies of them around the estate. So the job of this connector is to understand the size, and then it's to apply its protection policy. So here it's made 2 copies of the data, and it's spread it around the estate. So if this was a multi-site ring here, we can see that automatically the ring, just by using its normal addressing protocol, has made sure that these different copies are residing on not only different servers, but different sites. So we could tolerate, let's say, the loss of site B, we still have access at either site A or site C to that data. The other way that we protect data is with erasure coding. So it's typical, as you would see in any sort of cloud product. Erasure coding, generally we have it broken down into 12 data locations, but one of the value propositions of Scality is that we're super flexible. So we can have different applications on the same hardware with different erasure coding schemes, and you're not tied into any specific scheme across the whole array. These are our default based on the hardware and on the site layout and how most people want to protect it. But if the customer wants to go with something a bit more ad hoc, then we can support that. That's no problem. So in this example, we've got erasure coding 9.3, and this is for a single site. Basically, 9 is the amount of chunks that will break the original piece of data down into. And 3 is the amount of parity that we add. And because this is, we're adding 3 chunks, this is a 33% overhead. Remember, it's single site. So what we do is we've got 6 servers here. We logically divide each of these servers into 2 locations. So we've got 12 data locations on each. The application is going to write a 9 meg object to the connector. Connector is going to understand it's a large object, so it's going to perform erasure coding, and it's going to break that object into 9 1 meg chunks. And it's going to add 3 parity chunks, and again, it's going to randomly distribute that over the estate. And what that gives us the ability to do is lose 3 chunks. So we can always lose the second part of this number, the parity, and we can still have full read-write access to the data. And you can see here, it's not just the parity chunks that have disappeared. We've just lost a server, so the data and parity is randomly dispersed. So we've lost 3 chunks, and what that means in reality is we've lost 1 server and we've lost a disk in another. The benefit this brings is to play to our message of being 100% uptime, because we can take a server out, we can perform hardware upgrades, software operating system upgrades. We can let that happen. We bring the server back online, the data rebalances seamlessly in the background, and we move on to the next server. So this is how we achieve our uptime guarantees. This next example here is on a typical 3 site. So this is erasure coding 7.5, so 7 data chunks, 5 parity chunks. This is a 75% overhead, but remember this is spread out over 3 sites, so this gives us the ability to lose an entire site. So again, we've got 2 data locations on this server. This time, just to make the graphics and the maths easier, it's going to write a 7 meg object through to the connector. We break it up into 7 1 meg chunks, add the parity, randomly disperse it. We can lose 5 chunks, which equates to a whole site plus a disk in the other site. So in this instance, this site could be down for temporary reasons, either a power cut or a network outage, and it still gives us the ability to have disk resilience at another site. So we can lose a disk, and then once that disk is down, the system understands that, it rebuilds the data elsewhere, and we can lose another disk. So again, this all plays to our uptime guarantees and the fact that we keep the service online for as long as the customer wants. Just another example here, I'm going to rush through this. This is a 2-site, erasure coding 5.7. So 2 sites here, 12 data locations again. We write a 5 meg object, it gets divided into 5 1 meg chunks. We add 7 1 meg parity chunks. So we can see here we've got a lot more overhead, but the failure domain is larger, so we need that extra overhead. Gets dispersed randomly, so we can lose a whole site plus another disk, and so on. So I mentioned earlier on that we've got that the ring is synchronous, and this is where the stretch ring comes into play. So a few different modes of operation. We can have a single site ring. So all this data protection that I showed you earlier on is all about a ring. Think of a ring as a namespace or maybe a single storage array. So we've got a single site ring. Very few customers just want one physical instance of the storage. So they can either have the option to mirror the ring. So this is asynchronous, either over long distance or a poor network, or we can have the stretch ring situation. So stretch ring is where we take those 6 servers that make up the ring and we just put them on different sites. We give them good network connections, and then logically that's just one instance, but it's physically separated over 2 locations. And this is by far the most favorite approach that our customers take. Maybe 2/3 of our customers have a stretch ring of some sort, and then 1/3 have mirrored rings, and then maybe 1% have a single site ring. So with mirroring, with the asynchronous replication, because it's asynchronous, there's always going to be a point where you're behind. But this is well known. This is an industry standard type of asynchronous replication. So we've got a seconds RPO and an RTO, the same as the application. What is a good delineating factor for us here is the latency of the network. So if it's sub 10 millisecond, then we say a stretch ring is good. And actually sub 10 millisecond is quite generous. So this leads us into metro area networks or larger. I've got plenty of customers that have a stretch ring on good networks between, let's say, London and Birmingham. But generally it's on the outskirts of a city. So, a few data centers on the outskirts of London or whatever city they're in. If we're having a 2-site stretched, so this is where we have the data nodes across 2 sites, we'll always need a 3rd physical site just with some witness servers. These requirements are for small, thin, 1U type of servers with some flash storage in for the metadata. And it can be a lower bandwidth connection, but a similar latency. And this gives us the ability to lose any one of these sites, so one of the main data sites or the witness site, and still have read-write access to the ring because we've got the metadata witness, so we know we understand quorum of the data. And the RPO RTO here is 0, so we can access the same data at any site at any point in time, given a site outage. And then the 3-site stretch is the same RPO RTO as the 2-site with witness. Because again, we've got the metadata stretched over 3 sites, but we also have the data stretched over 3 sites. So this is beneficial in terms of the overhead, that 75% overhead I mentioned earlier on. And same metro area, sub 10 millisecond latency. So we can access this object store either by file or S3. I'll just talk about some of the benefits of file. So we can choose the different connectors. It could be SMB version 3, NFS version 4, Fuse or REST. So REST is a super basic get, put, delete type of object functionality. This can bridge the namespace between file or object for us. Or it can be Fuse, so we can sit directly on some application servers and we can present the ring as local storage to those. But mostly we see it's SMB or NFS. And this is typical either. It's either driven by the application, so one of those ISVs that I listed earlier on, or it could just be a basic, researcher type of share. So we've got quite a few research institutions that just expose an SMB share, and things like microscopes are connected to that share, so they'll save the data locally. The researcher will copy out to their local, to their share, to their area on that share, and they'll manipulate that data and then copy it back to an archive The way it works is we have metadata always stored independently to data. So data is protected, like I said earlier on, with either erasure coding or replication, and it's heavily durable across the ring, across the sites, across the servers. You can deal with any level of failure. But the metadata sits on the flash drives in the same storage nodes, so those same servers as we've got earlier on. The metadata just sits on a mini ring there, and it's protected with 5 copies of the data. So metadata is heavily protected as well. And again, having 5 copies of the data will always ensure as quorum of data and the ability to access that metadata given the loss of a site or other resources. So we can offer things like volume protection. So that's just worm. So this is great for our medical customers. So, you know, think of an X-ray as being a non-changing fixed object that stays, and you want to keep that forever. So you want to protect that against accidental or malicious deletion. So we can do that on file. We also have the ability to do some form of file versioning. It's a fairly basic form of file versioning that will keep an older version of the file when it's updated. Also, we have the ability to view an existing file system, an existing Scality file system through the S3 API. So this is good when we look at Scality, you know, offering this future-proof sort of storage. So we can start with file, we can move that application to S3, but once that application's moved to S3, they can also access that existing data, you know, via this bridge, so they can view it as S3, but it's actually file data on the back end. And we've also got another way to do this using the Zenko or extended data management product. So we can also look at the Ring as an S3 store. Some of the benefits of our S3. So we very closely monitor the AWS API. We introduce new features as and when they are necessary or as and when customers ask for them. And a prime example of that is, like I mentioned earlier on, Beam 10 with the object lock API and the immutability of that backup. So that's something that we wrote into the product and released in the last version of Ring. So we tend to track the API as closely as we can. We can't track it 100% like some of our competition claim to do because we're on premise. You know, you can't do things like account management through the API. So we've got a GUI and we've got a separate set of APIs to do with account management. And by that I mean things like, you know, collecting a customer's credit card details. There's no need for that because we're an on-premise storage. Where we do replicate AWS is things like IAM. So we have the same logical concepts. So if you were looking at a service provider, what a service provider would do is basically create an account on the Ring, and they would hand that account over to the customer. That customer would then own the keys and the management of that account. So they would create users, they would create buckets, they would give users access to buckets, and we can do policies and groups to help in that administration. We can even link the S3 IAM up to an existing Active Directory structure, so we can import all that data, and that can just save on implementation. The benefits of Scality and an on-premise object store, you know, we don't have any limits in terms of quantity of buckets or the number of objects in a bucket, or even the size. So we're not bound by some of the limits that AWS imposes. Actually, we've created sort of multi-petabyte size files, and we can access those without a problem on the Ring. Again, it's the same benefits as the file connectivity. Metadata is spread across all the storage nodes, so we can deal with failure of hardware at any point. We've got something called the utilization API. So this graphing here we can see is just part of our GUI. And this just shows some of the metrics that the GUI pulls back. So we can see capacity, performance. We get a breakdown of the HTTP codes that have occurred against either this account, bucket, or user. So we can cut sort of performance and metric data at any of these levels. We can also encrypt data either in flight or at rest for S3. We can encrypt data at rest for any data, file data or S3 data. But with S3, we also have the ability to to encrypt at a bucket level and pass that through the entire estate. Also with S3, we've got the ability to version and worm. So similar to file, we can worm the data. We can also version it. So there's now two levels of versioning. So we can just version the entire bucket, and we do that by policies. So we have policies that say that you can save the data once, but you can't amend it, you can't delete it, and we apply that to all the users. So that's effectively worm. And then the other level is, like I just mentioned earlier on, the object lock API, which is application driven, which gives the application the ability on a per object level to set the retention period. And also bucket location control. So, like you do with AWS, you could have a bucket in the East region or the West region. Then we can define an endpoint. So it could be the same endpoint, but the API writes onto it the region, which could then define which physical location the connector saves that ring data into. So it could be, for example, in England or Italy, or we could just even use it to send it to a different erasure coding schema. So again, there's a lot of flexibility on how we design the connector to work with the application and the needs of the customer at that point. So in terms of ring management, we've got a GUI. This is just a screenshot of the GUI. So it's pretty informative. It has a whole bunch of standard graphs and alerts. We have the ability to dive deeper as well. So you can create a whole bunch of custom stuff, which a lot of my more enterprise-based customers do. So for example, they'll have some detailed graphing set up for, let's say, some backup jobs that they put on their screens, or the CCTV customers will have some graphs that show the throughput of the CCTV connectors during events, or even if it's play out or CDN for a media customer. Again, we can sort of monitor at any level, and it could be a processor, it could be a disk, it could be a server, a network, anything that you can think of monitoring, we can obviously do that in the GUI. S3 console, so this is how we manage S3 and IAM policies. So we can see here we've got users, so we can create users and we can apply groups and policies to those users. So we can have a policy that allows any users in it to write data, or we can even have policies that stop people querying buckets or querying the objects within the buckets. So we can start reflecting exactly what level of complexity or detail the customer needs. Or, to be truthful, a lot of customers just use us behind an application, in which case it'll just be a simple application user with their credentials. So they would have a secret key access key for that application. So in terms of monitoring, we've already seen some of the detailed on-premise monitoring that the Ring GUI can offer. We also offer a replication of that within the cloud monitoring. So basically, this just takes the same sort of stats that we can collect locally. It just copies it to the cloud location so that Scality support and even me, I can have a look in at my customers on a weekly basis and just see how their Ring is performing and how their capacity is looking. And in terms of security, I've mentioned we've got encryption of data at rest or in flight with S3. We've also got at rest encryption, which is powered by the RAID controllers. And also we've got role-based access control for the Scality management. So we can have an administrator that can see and do everything, and we can have read-only users that can just view data. So I'll just take a few more minutes to talk around Zenko. So Zenko is our multi-cloud product, and this basically, it exposes an S3 front end. So obviously S3 is the sort of current de facto cloud API that people use. But one of the benefits of Zenko is it can talk to any cloud backend. So it can talk to AWS, it can talk to Azure, it can talk to GCP, and it speaks natively in that cloud's language. So when we start looking at having all these different backends, different cloud backends, if we include the Ring with that, we can see how Zenko can become a powerful search engine or a powerful workflow controller across all these different locations. So there's 4 pillars. So this is one that I mentioned already. It stores all data unmodified in that cloud's native language. So we can use Zenko to move data from Ring to Azure, for example, but we don't have to use Zenko to get that data back. You could just go to the Storage Explorer in Azure, and you could see that in the GUI or the Explorer, and you can pull it back, and you can use that cloud's native functionality to enact on it. So you might want to, for example, move some data to Azure to do some AI on it, or you may want to move a different set of data to AWS to do some CDN functions, and Zenko will allow you to do that. Zenko allows the addition of custom metadata. So we have a whole bunch of standard S3 metadata, but we can also add custom metadata, and we can search on that. Also, one of the benefits is that we can use the standard S3 protocol, so things like lifecycle or transition policies, to move, copy, or delete data around the estate, and we can use the custom or the standard metadata to do that. So we can start using pretty granular workflows. So we might have a bucket. Lots of our media customers use this, so they might have a bucket on the edge that some of their providers have content to, that they drop in. Let's say an episode of Game of Thrones that gets dropped into this bucket. Zenko realizes some new activity on that bucket. It checks the rules, it copies it into a more secure bucket in premise, and it deletes the one on the edge. And then it can notify some other controller or database that then imports metadata, and then moves it through the system and through the estate, queues it for play out, and then queues it for deletion after the license to use that has run out. So we can start getting some pretty granular workflows. On the flip side, we can also use that for a pretty basic workflow. So we could have a Ring that's on premise. It's got a whole bunch of data in. Some of that data is not used. So we could have a policy that say any data in bucket X that hasn't been accessed for 6 months, just move it to cloud. So we can move it to AWS. And then we can even move it out to Glacier on the back of that. So we're going to cooler, colder, more cost-effective cloud storage as well. And I've already mentioned that we can search the entire estate. So you can enact a search through the Zenko GUI or the S3 API that searches the locations for names or metadata about these arrays. One of the features that we've recently introduced into Zenko is the ability for it to scan an existing file system. So you might have an on-premise, let's say a NetApp array that you have some shares exposed from. So Zenko could scan that file system. Then what it would do is it imports that metadata into its own database. So the existing file data is still there in situ in place, but Zenko now understands that, and it now views it as an S3 object. So it can search and you can pull back that data as if it were an S3 object. So yeah, so it's an S3 front end, storage location backend. So any backend, it could be Scality Ring, could be AWS, Azure, GCP, DigitalOcean, Wasabi, anything that's S3 compliant as well. Some of the data mobility that I didn't mention earlier on, so we can have replication. So we could have a bucket that's on premise on a Scality Ring, and we could have that bucket replicated to AWS. Or we could have one-to-many, so we could have that bucket on premise, and it could be replicating to AWS and Azure, as well as some of the data movement policies that I've talked about, the exploration and transition. So when you think of something like a backup job, maybe, and I know this functionality is coming in something like Veeam 11, but we can do this today, where you have an on-premise Veeam, and it saves some local data to the Ring, and then the Ring with Zenko will push that data out to different locations, just securing that backup forever. And Zenko is managed through a GUI called Orbit. In the next release of Ring, the management is going to come into the same GUI as Zenko on premise. Some use cases, so Cloud DR or HA for data. We've got a large customer in the States, a large pharmaceutical customer that did a cost analysis and decided actually it's not worth having 2 data centers for DR or HA. So they've just got one primary data center. This is a good story because they also use us with Weka.io. So they use Weka for some HPC scratch space. It tiers out to an on-premise Ring, and then also that on-premise Ring replicates that up to different locations in the cloud. So in essence, cloud becomes their version of DR or HA. So it's not for everyone, but this is a good example of a use case that Zenko can be used for. We can also use it as a distribution for IoT, so maybe from edge to core. So we could have lots of mini instances of Zenko that sit on the edge. Maybe an example is maybe wind turbines or something like that. So you've got some compute in there that is capturing performance of an object. It then sends it to a local instance of Zenko, which then replicates it back to the ring. And then, of course, the ring can just have multiple copies. It can back it up. It just preserves it for a long amount of time. So you can be thin on the edge and thick in the core. Content distribution, I talked around this with some of our media customers. So we can use Ring and Zenko together to be able to move data around the estate. And again, just some of our ISV partners that we work with that also fit into the fact that we can be on premise or in cloud. So I've mentioned Veeam quite a lot because they're bringing that functionality into their product. But it works with anything. So anything that's on premise that you think you want to keep, or you want to move, or you want to tier out somewhere else, then Scality, Ring, and Zenko can do that. So yeah, the one purpose of Scality is to give freedom and control to people who create value with data. So you can create the data, we'll look after it indefinitely, forever. We'll make sure you've always got access to it, whether that be on premise, at the edge, in the cloud, and it's super heavily protected. So I'm conscious we're coming up to 10 minutes. I've whisked through that presentation. Did any questions crop up whilst I was running through that? Is there anything that you need me to go back to and revisit?
We didn't have any hand raises. Oh, Doug has just raised his hand. Okay.
My fault, hit the wrong button.
Oh, okay.
I have the power. I'll put your hands back down. Yes, it works. No, if anybody else would like to shout out, or we do also have a chat function as well. Alternatively, what I will do is I will, in the chat, I will put the email addresses of myself, of Doug, of Rob, and of Sean Mullin. Feel free, if you would like to contact us outside of the parameters of this meeting, we can do that as well.
Absolutely. And did Sean want to take up a few more minutes as well?
Thanks, Rob. It's just one more slide that I'd like to share, if that's okay. I'm just going to pull up my screen quickly.
Well, whilst you're doing that, mate, I'd like to point people to vote for the Storage Awards. Scality's up for 3 awards: one to Watch Company, Object Storage Vendor of the Year, and also Cloud Storage. So please vote for us.
And something else I wanted to mention as well is if you're interested in having some further deeper education on this, then we run the Scality Architects. So you can just engage with Doug or myself, and we can look at getting you included on a remote education session that gives you a certificate at the end as well. Thank you.
Thanks very much, gents. I think, really just to kind of wrap up and add to the great overview that Rob and Doug have given today. One of the things that the gents talked around is obviously scalability is a key part of this. I just wanted to talk to the fact that the 4 configurations that I mentioned at the start that we have are basically based around 2 of our platforms, which I'm going to flash up in just a moment. But essentially, in terms of what we recommend for optimal performance using the Scality Ring appliance, we do suggest using 6 nodes to achieve that scale out, or at absolute minimum using 3 nodes for your minimum cluster size. The next slide here, so don't worry, I'm not going to follow up with a whole deck worth of materials again as well. I just wanted to flash real quickly, these are the 2 recommended solutions within our Supermicro product portfolio that we suggest using for the Scality Ring appliance. So the one on the left, the Simply Double, aptly named, you can see from the photo. Essentially, we have 2 offerings based on this platform. So we either suggest fully populating it or half populating it within a cluster of 6. And again, we also have the top-loading 60-bay storage solution for Scality. And again, it's either fully or half populated. So these are effectively, we've got 2 platforms, fully or half populated, to achieve those clusters. Outside of that, if your customer or end user has a more specific requirement where we need to tailor or tweak the hardware solution to cater for what they're trying to achieve with the Scality Ring platform, we can of course do that, and that's something that the Northamber team will be able to help you with as well. So that was it. I just wanted to share that real quickly, Jodie, before you wrap up. Thank you.
So just one more thing on the back of that is I hope you can see and appreciate the flexibility that a solution like Scality on Supermicro hardware can deliver. So we can start, meeting a customer's initial requirements, and we can very easily just add more and more use cases onto that and add more and more applications and just scale indefinitely, really. So, thank you.
Fantastic. Well, to Scality and to Supermicro, thank you very much for presenting today. Really exciting collaboration. It is really nice to be part of. Some great strong messaging that we can take to market. It won't be the last that you hear from the three of us, so do expect to have more presentations coming along soon. As I said, I've put everyone's contact emails in the chat. You're welcome to reach out to us independently if you would like to talk to us about something. Everyone who's also joined as well, we will send out the recording, so some late night viewing if you want to review some of the slides again. As I said, please reach out if you've got any questions at all, and thank you for taking the time to spend with us this afternoon.
Yeah, thank you, everyone.
Cheers, everyone.
Thank you. Bye.
Thank you. Bye-bye.
Bye-bye.